So in this question, we're told we have a ladder that is to be moved horizontally around a corner from a 3-meter wide hallway to a 2-meter wide hallway. Determine the length of the longest ladder that can make this turn. Neglect the thickness of the ladder. So the key to this question is the diagram, okay? I've got my 3-meter wide hallway, I've got a right angle, I've got my 2-meter wide hallway, and I've drawn this line in the middle that represents my ladder. Okay? And the longest possible ladder that can fit through here is really the ladder that is the same length as the shortest possible distance from this wall here to this wall here, where it also hits that corner right there. If I can get my ladder through that sort of configuration, then I can get it all the way through the corner and around into the 2-meter wide hallway. So since this unit is on trigonometry, you can imagine that we're going to model this situation using some trigonometric functions. And what we want to minimize or maximize here is the length of the ladder. So I'm just going to say, I'm going to let L be the length of our ladder here. Okay? I'm going to take that expression for L and I'm going to break it up into two smaller expressions. I'm going to say an L1 and an L2. Okay. L1 is going to be the distance from my one wall to that central point, and L2 is going to be the distance from that central point to the end of my ladder. What this lets me do is draw a couple of right angle triangles in here with L1 and L2 as the hypoteni of my triangles. Okay. So in each of these two triangles, I know the length of one side. I know that this one here is 3, and I know that this one here is 2. Okay, and I know the length of, and I have an expression for the length of the hypotenuse. I also know that these triangles are similar. So if I say that I want to do this in terms of this angle theta in here, this angle here will also be theta. So now we just need to use a little bit of right angle trigonometry and figure out expressions for L1 and L2. So in that top triangle, we have L1 is our hypotenuse, 3 is our opposite side. So which ratio relates the hypotenuse and the opposite side? That's going to be our sine ratio. So sine theta is opposite over hypotenuse. So we can rearrange this to get L1 is 3 divided by sine theta. In our bottom triangle, we know that, let's see, we've got the adjacent side and we've got the hypotenuse, so we have to use cos. Cos theta is going to be that adjacent side over hypotenuse, which is L2. And now we can rearrange to get an expression for L2. 2 divided by cos theta. So this is going to be a little trickier than the last example because our trig functions are down in the denominator of our function. Okay. But let's put this together here. So L1 is 3 over sine theta. L2 is 2 over cos theta. Now, the textbook does an example of this kind of question. What they do at this point is they replace 1 over sine theta with cosecant theta, and they replace 1 over cos theta with secant theta. They use the reciprocal trig functions. I can never remember the derivatives of reciprocal trig functions, so I'm going to keep it in terms of sine and cos. I find that easier. Okay? But what that means is I have to make these into composite functions. Instead of 3 sine theta, I'm going to do 3 sine theta to the negative 1. Instead of 1 over cos theta to the negative 1. Okay? And this is the expression that I'm going to take the derivative of. So let's do it. Take our derivative, set it equal to 0, and then solve for theta. So my derivative is going to be 3, bring down the negative 1 to get negative 3, sine theta to the negative 2. Chain rule, I've got to do the derivative of sine theta which is cos theta. Add on to this the derivative of the second term, so I'm going to bring down that negative 1. I'm going to get negative 2 cos theta to the negative 2 times the derivative of cos theta. Derivative of cos theta is negative sine theta. Okay. Now I've got to set this whole thing equal to 0, and I've got to solve. Well, what am I going to do now? I'm going to take those sine theta and cos theta with the negative exponents, and I'm going to turn them back into fractions. So I'm going to have negative 3 cos theta divided by sine squared theta. My negative 2 and my negative sine are going to cancel out, so I get a plus 2 sine theta divided by cos squared theta equals 0. How am I going to solve this? Well, I've got a negative 3 cos theta over sine squared theta. I can easily bring that to the other side, okay, to give me 2 sine theta over cos squared theta equals 3 cos theta over sine squared theta. Now, the next trick I'm going to do is I'm going to cross multiply. Okay? Cross multiplying here sort of combines all of my sine thetas and all of my cos thetas together. So I'll have 2 sine cubed theta equals 3 cos cubed theta. And now we're going to do something similar to what we did in the last example. We've got sine cubed theta, we've got cos cubed theta. I'm going to divide both sides by cos cubed theta. Okay? And I'm going to divide both sides by 2 to get 3 over 2. Okay, so just rearranging those fractions. Sine cubed theta over cos cubed theta is going to be tan cubed theta. So the equation I need to solve here is tan cubed theta equals 3 over 2, or tan theta equals the cube root of 3 over 2. And I'm just going to plug this into my calculator. So inverse tan of the cube root of 3 over 2. I'm going to do this in, my calculator is in degree mode. So I plug this in and I get theta equals 48.86 degrees. Is that my answer? Well, what were they asking me in the original question here? They asked us for determine the length of the longest ladder. So I have to take that value for theta and plug it back into my expression for length. So the length is going to be 3 divided by sine of this 48.86 degrees plus 2 over cos 48.86 degrees. A lot of button mashing later, and I end up with 7.024 meters. So the longest possible ladder that I can get through this little corner is going to be about 7 meters long. So the key trick to solving this, I think the trick that you want to remember is getting it so you've got sine of something, cos of the same thing on the same side, then you can convert that into tan, and then that just becomes one trig solution that you need. Also in this question, we had a restriction on theta that we really didn't talk about, but again, theta in this question was restricted to being between 0 and 90 degrees. Because if we go back to this original triangle, if we tried to make theta greater than 90 degrees, we end up putting the ladder into the wall, and we're not allowed to do that. Okay? So usually in these optimization questions for trig functions, you're limited to your quadrant 1 solution. So the solution that your calculator gives is usually going to be the only one that you want.